Okay, so the differences between one value in a data set and the mean is referred as deviation, and the standard deviation is the average distance from the mean data. Okay, so there are 4 students sitting at the table. Their age as follows: 22, 19, 19, 36. Now, the first step is, how do we calculate the mean? So the mean is going to be the sum of all of the age and then divided by the sample size or the number of the student. So we have a formula like this one: 22 at 19 at 19 at 36. We totally have 4 students, so we divided by 4. Now we have 24. So that means the average of the students, the average age of the student is 24. Now find the deviation of the age, which we use the age subtracting by the mean to get the differences. So in this case, we have 22, because the first student age 22 minus the average age, the distance is, -2. And then with a second student 19, subtract 24, which is -5. 19 subtract 24 is -5. And then with 36, subtract 24, which is 12. So here gives us the idea of the distance from mean. So think about that. 24 is here, 22 is here. So 22 and 24 is -2. When it comes to 19, your distance is going to be -5 from the mean. So here is our 36. So 36, the distance from the mean, which is the average, is +12. So now, because the negative distance doesn't exist, we look at the square of each distance. So that means you want to square the distance. So -2 squared gives you 4, -5 squared gives you 25, -5 squared we have 25, and then 12 squared we have 144. Then to average the squared deviation, which is the distance, we square the distance. Deviation is distance. We add them together, but instead of dividing by just the sample size, we need to use the sample size -1. This is called the degrees of freedom. So the average is called variance. So now we're trying to get the variance. So for the formula, let me use different colors of pen. Oops. Variance. So what we did earlier is we use each data set subtracting the mean, the sample mean, and then we found the distance. We square the deviation, which means we square the we square the distance of the deviation, and then we add them together. Remember, this notation means sum, and then we divided it by the degree of freedom. The degree of freedom is equal to the sample size -1, sample size and -1. So here is our formula. Okay, so how do we do that? Now let's take a look. We already squared them. Here is the data. We just need to add them. We have 4 at 25, at 25, at 144 divided by the sample size -1, which is divided by 3. So we have 66. So variance equals to 66. variance, we use this notation. Okay, so we need to make up for the fact that we square our unit. So we need to take the square root. So the square root of the variance refers at standard deviation. Okay, so now all we need to do is standard deviation. We use, let me write this down, our standard deviation is equal to the square root of the variance, which in this case is going to be the square root of the sum of each this guy, right? So what we did earlier, we found out that, hey, we want the square root of our variance. So that square and square root, they cancel. That's why you got the sigma. This is called sigma. In our case, it's square root of 66, which is equal to 8.12. So our standard deviation is 8.12. So in here, I want to show you another way to calculate this deviation by using an Excel. Okay. To start with, you open a new tab and type in Google Sheet, or you can also use Microsoft Excel sheet. They are the same. Let's go to have a new spreadsheet. So the first thing you want to do is you want to type in your data. In this case, we have people with different ages: 22, 19, 19, 36. Now, the next step is we want to find the mean. In fact, they have a built-in function to help you to find mean. All you need to do is type in equal and type in mean, and then choose the data that you want to take the mean with, and then put them into parentheses. Oops. So in here, in Google Sheet, they don't have a mean function. We can use average, and then also highlighting the data that you want to take average at. So press return, and then you will get the result 24. Remember that in here is your average, or I can put it in here so I know that in this parenthesis is going to be my mean. So again, your function is going to be average. You choose that and highlight it, this part, type it. Please try it by yourself at home. All right. So now after we found our average, the next step I want to do is use our H data to subtract the X bar, to subtract our mean. Okay, so that means I want this is equal this number, subtract 24, or subtract this part. So the reason I use a function instead of typing the real number is because, okay, if I type in the number wrong, if I change the data, the value in here, which is 20, the whole function is going to change it automatically for you, so you don't need to recalculate that by yourself, which makes it easier. So here is the same. I use the second data and then subtract this one, equal this guy, which is A4, subtract B7. And after that, they might already know what you want. A5, subtract B7. So that gives you the data, subtract the mean, which gives you this, the distance, right? Or the deviation. And then the next part is you want to square the deviation or square the distance. Okay, to square, which is equal to this guy, square them. And then again, they will give you a autofill, suggested autofill. All you need to do is just click yes, because the autofill, because they predicted that, hey, you want to square these this tab, which is B3, which is 25, okay, which is correct. You also need to check by yourself. When you click in here, you will see on the top, it shows you the function. The function tells you that, hey, in this, the value of this tab is equal to B4, which is the highlighted dash box, and then square. Okay, after we square the distance, the next step, followed by the next step, is you want to get the sum and then divided it by the degrees of freedom, which is n minus 1, to find the variance. So our variance equals to function, the sum of, now we can choose the value, the square of the distance, right? And then divided by n minus 1, which is 4 minus 1 divided by 3. So now it gives you the variance equals to 66. And then the next one is you want to square the variance. After you square root, take the square root on the variance, then you get the sigma, which is our standard deviation. So our standard deviation is going to equal to the square root, SQURT. This is the square root. It tells you the positive square root of a positive number of this guy. I don't like typing 66. I like to type in the function D7, because like I said earlier, if I want to, I type in, I notice that, hey, I made some mistake when I input the data. I put 29 instead of 19. Then I can switch it back immediately without messing around my table, as long as I put the formula correct. Look, it will automatically do that for you. So I really like using the Excel sheet. Of course, they can have other sheets to help you, such as Desmos or GeoGebra. You can explore it by yourself. Now, after we're done with these, let's explore more of our get back to our lecture. Now, take a look. For symmetric data, we discussed it in the last video. We use mean and the median for symmetric data. Because, why? The mean is not resistant to the outliers. If there's outliers, you will not get a symmetric data. You will end up to have a skewed data. So we want to use the mean and standard deviation when it comes to symmetrical data to describe the center and the spread of the data. We would not use these to describe the skewed data. Because since the values themselves are skewed and they would not accurately represent the data. Okay, so deviation is we use each data to subtract the average, which gives you the distance, and then we square the deviation, which is square the distance. The variance is the sum of the square deviation and divided by the degree of the freedom. The degree of the freedom is n minus 1. And then when it comes to the standard deviation, it's taking the square root of the variance. Okay, so here is how do we calculate the standard deviation for the following data set. I can do it one by one. Okay, so the first step is you want to find the sample mean, which is the sum of the data and then divided by the sample size. In this case, it's going to be 5. So we have 12.2. And then the next step is we want to find the deviation. Our deviation, we have 3 minus 12.5, 8 minus 12.5, 11.2, and then 12 minus 11.2, 15 minus 11.2, 18 minus 11.2, and then equals to the distance Now, we want to square. The next step is we want to square the deviation. We square them. All of this square, we have 60.24, 10.24, and then square point 8, we have 0.64, square 3.8, we've got 14.44, 46.24. Now, after you square them, you want to add the square deviation and then divide it by the degree of freedom. Okay, then we got the variance. Variance equals to 60.24 at 10.24 at 0.64 at 14.4 at 46.24, and then divided by the degree of freedom is, you have a sample size of 5, degree of freedom is going to be 5 minus 1. So your variance is equal to 34.7. And then our standard deviation is equal to the square root of the variance, which is 5.89. So here is the step, the detailed step, show you how to get this deviation. Again, we can use our Google Sheet to help us. So in here, it makes it easier. We can change the data to 3, 8, which is nice. They will automatically change that for you, but you need to add another one. In here is going to be 18. So the mean minus data is going to equals to, yes, they're already making a guess for you. 24 point, but we need to change the mean because at beginning our mean is from A2 to A5. Now we're adding an extra data, so that means our mean is going to be A2 to A6. You want to include the fifth data. So here our new graph. So here shouldn't be now. Let's go back to check. In here, this one should be A6 minus, not B12. We want to minus the mean, which is B7. Okay, and then we square them. It will automatically do that for you, except for this one. We want to square this part. See, they're already making a guess. Know that you want to square the B6, which is our 6.8. All right, and the variance, we also need to change that too, because at beginning, we're adding the sum of the first 4 data. Now we're adding another one. And the degree of freedom, we change that to 4. Okay, now we got the data, exactly what we found now. So please practice the Excel sheet by yourself at home. You might need to use that during your test or quiz. So in your quiz, what I expected is I want you to show me all of these detailed steps. You can help an Excel sheet to help you, but I still want you to show me the steps. Okay, so here's another example. So let data set A represent the number of people visiting a certain cafe on 5 randomly selected days. Describe the center and spread for the data given the data is symmetric. So now let's analyze it. What do we find? So we found out that the mean is equal to 12.2, and the variance, or the standard deviation, is what we care about. The standard deviation is equals to 5.89. So in here, the number is represent the number of people visiting. We know that when it comes to visiting a number, we don't have 11.2 people. So you need to round this number to a whole number. Okay. So on average, this is what we found. There are 11 people visit the cafe. And this varies by about 6 people. So varies, which is our standard deviation, that tells you that this is give or take. What does that mean? That means sometimes you will expecting 11 people to come to visit, but on average this may be varies from 11 minus 6, which is 5 people, to 11 plus 6, 17 people will come to visit. This is most likely to happen. Okay, so that's it for how do we analyze the symmetric data.